Hi class, this is the second video for Unit 2, Analyzing Data. Today I'm talking about scientific notation, specifically how to starting over. Hi class, welcome back. This is Unit 2, Analyzing Data. This is the second video. So in this video, I am talking about scientific notation. Specifically, we are talking about adding or subtracting in scientific notation, and later multiplying and dividing. So we have a pretty easy time with scientific notation these days. School gave everyone a scientific calculator. We have access that makes it pretty easy. In this video, I want to show you how to do it the old method, where we don't necessarily use calculators, because I want you to know that this can be done by hand. So the first thing that we do, we have to make sure that the base and the exponents are the same. Now the base for all of these is 10, so that's not going to be an issue. But the exponents need to be the same before they can be added together. Then we add or subtract the numbers, which are called coefficients. So in example 3, I have this first one, 3 times 10 to the 5th plus 3 times 10 to the 5th. Now both of these have the same base of 10, they have the same exponent of 5, and so we're good to go here. We can go ahead and add these numbers together. So we have 3 plus 3 is 6, and then it's times 10, and the exponent is going to be the same, times 10 to the 5th. In this next one, it's a little bit different. We have 2 times 10 to the 4th power plus 2 times 10 to the 3rd power. So with this one, we have to make sure that their bases are the same, and they are. We have to make sure the exponents are the same. They're not. So what I'm going to do is change this one. 2 times 10 to the 4th would be the same thing as saying 20 times 10 to the 3rd. So now I have 20 times 10 to the 3rd plus 2 times 10 to the 3rd. And so my answer here, or at least the next step, it is 22 added together, and it's times 10 to the 3rd. Now this is not in standard scientific notation. We're going to have to fix it. So the decimal is located here. We need to move to the left 1. When you move the decimal to the left, it makes your exponent more positive. So we're going from 3 to 4. 2.2 times 10 to the 4th power. And the next example, we have 5 times 10 to the 30th power and 3 times 10 to the 31st power. So in the last time, we made the larger exponent smaller, and then we had to fix it at the end. This time, I'm going to make the smaller exponent larger, and we'll see how this works out for us. So if I move the decimal 1 to the left, I can make this 0.5 times 10 to the 31st. Plus 3 times 10 to the 31st. And what I come up with, I add the two coefficients, 3.5, base is 10, and the exponent stays the same at 31. For subtraction, it's going to work about the same. The bases and the exponents must be the same, and we're going to subtract the coefficients. So in this first example, both of them are times 10 to the 12th power. So we're okay to go ahead with this because they're the same. So subtract your coefficients. So 9 minus 4, there's 5. And the base and the exponent stays the same. 5 times 10 to the 12th power. In this one, we have 5 times 10 to the 8th power minus 3 times 10 to the 7th power. The exponents are not the same. So I'm going to change this one, 3 times 10 to the 7th, to 0.3 times 10 to the 8th. I'm moving the decimal 1 to the left, and I am making my exponent increased by 1. Now that my exponents are the same, I can go ahead and subtract. 5 minus 3 is 4.7, and both of them have times 10 to the 8th. And so we're good to go on this one. In the next example, we have 6 times 10 to the 9th minus 8 times 10 to the 8th. And I'm going to do both strategies here. I'm going to make the larger exponent smaller. So I'm going to change 6 times 10 to the 9th to 60 times 10 to the 8th. So we have times 10 to the 8th for both. So we have 60 minus 8, 52, times 10 to the 8th power. And we have to fix this one. It's not standard scientific notation. So we're going to move the decimal place 1 to the left. That's 5.2. And when we move it left, it becomes more positive. We're going from exponent of 8 to 9. The next thing to look at is multiplying or dividing numbers in scientific notation. So for this one, the first thing you can do is multiply or divide the coefficients. For multiplication, we are going to add the exponents together. For division, we're going to subtract the exponents. Then, as a last step, we will adjust the exponents so that the answer is correctly in standard scientific notation. So in the first one, we have 3 times 10 to the 5th times 3 times 10 to the 5th. Multiplying. Multiply the coefficients. 3 times 3 is 9. Times 10, and we are adding the exponents. 5 plus 5 is 10, and we get 9 times 10 to the 10th power. In this next one, we have 5 times 10 to the 2nd power and 6 times 10 to the, kind of blurry, let me double check it, 8th power. So we're multiplying the coefficients. 30 times 10, 2 plus 8 is 10. Now this one, we have to adjust the exponents because this number, the coefficient, is not between 1 and 10. So we have to change it. This is going to be 3 times 10, and we move the decimal point from here to the left. So we're at 10, then we're at 11. 3 times 10 to the 11th power. In the next one, we have 8 times 10 to the negative 4th power times 2 times 10 to the 6th power. 8 times 2, we have 16 times 10, and we're going to add the exponents. Negative 4 plus 6 is 2. And then we have to adjust it. So my number between 1 and 10 is 1.6. We're moving the decimal to the left, which makes it more positive, so it's going from 2 to 3 times 10 to the 3rd power. The next one, 3 times 10 to the negative 3rd power, 4 times 10 to the negative fourth power. Multiplying the coefficients gives us 12 times 10, and negative 3 plus negative 4, negative 7. We need to adjust it, make our number between 1 and 10. So here's 1.2 times 10. And as we move to the left, our number is becoming more positive. So we're at negative 7. Here we're at negative 6. For dividing, we go ahead and divide the coefficients first. Then we are going to subtract the exponents. So we have 4 divided by 2, coefficient is 2, times 10, and we have exponents of negative 4 and 2. So 4 minus 2, 2 times 10 to the second power. So we have 9 times 10 to the fifth divided by 6 times 10 to the third. 9 divided by 6 is 1.5 times 10, and we are doing 5 minus 3, so we have 1.5 times 10 to the second power. 2 times 10 to the negative second divided by 2 times 10 to the negative fifth. So we have 2 divided by 2, that's 1, times 10, and we have negative 2 minus negative 5, which is the same as saying negative 2 plus 5, 1 times 10 to the positive third power. 1 times 10 to the negative first divided by 5 times 10 to the negative third. So we have 1 divided by 5, that's 0.2, times 10, we have negative 1 minus negative 3, or negative 1 plus 3. So the exponent is 2. And then we need to fix it to make it appropriate scientific notation. So we're moving it to the right one. Our number is 2. When we move to the right, the exponent becomes less positive. So we're going from an exponent of 2 to 1. 2 times 10 to the first power. Some notes here. You can use your scientific you can use your scientific calculator to do all of this. It has the capability. For our school, we are using a TI 30XS. The TI 30XS is okay. It has one little problem that we'll get into in a second. But it does scientific notation. It has a button for scientific notation. So when you're doing scientific notation, you're going to enter the coefficient. So let's say we're talking about 3.1 times 10 to the fifth power. So you're going to enter your coefficient, 3.1. Then you're going to push the button that looks like this. It's in the top half. It's dead center of the top half. It's a blue button and it says x 10 to the nth power. So you hit this button, x 10 to the n, and then you type your exponent. And that's all that you have to do. That is your scientific notation. There is a second method, and it's a little bit longer. It still works. This is what I normally see students doing when they first get to my class. They are typing 3.1, they're hitting times, then they're typing 10, then they're searching for the caret button, and then they're typing 5. It still works the same, it's just now they're hitting 3 extra buttons and it just takes longer. There is one button that does all of that. The last thing about it, the school issued calculators, that TI-30XS, it needs a specific input to work appropriately. Anytime you enter a number in scientific notation, it needs to be put in parentheses to make sure that you don't mess up the order of operations. If you don't use parentheses, then your order of operations will be off, and it'll give you a weird answer. So this is what it's going to look like. If you had 6.02 times 10 to the 23rd, you would enter it as parenthesis 6.02, hit the X 10 to the N button, and then 23, and then close the parentheses. This is how you're going to need to input it. If you have a different scientific calculator or a graphing calculator, they're all different in terms of their button placements and what the button even says. You can come see me after class, before class, and I can help you figure it out. As far as the parentheses go, there is one specific thing that you'll see in my class, then you'll automatically know that your answer is wrong. So let me give an example here. Let's say we're going to divide 4 times 10 to the 20th divided by 2 times 10 to the 20th. Actually, let's make it look a little more realistic so you see exactly what's going to happen. 4 times 10 to the 23rd divided by 2 times 10 to the 23rd. Now we can use the method that I just told us about at the top of the page for dividing. So we are going to divide the coefficients, there's 2, and we're going to subtract the exponents. 23 minus 3 is 0, so 10 to the 0th power is just 1, so our answer here is 2. Here's the problem you'll get with the calculator if you type it in without the parentheses. This is the answer it's going to give you. It's going to say 2 times 10 to the 46th power. And this is wrong. The answer was supposed to be 2. We figured it out in our head. This is what it should have been if we used parentheses. Instead, this is what the calculator gave us, something with the order of operations. In my class, there will never ever be a question that comes out to times 10 to the 46th power. If you see an answer that is times 10 to the 46th power, you can bet that it's wrong. 100% of the time, there's not a single question I'll ask you where the answer is times 10 to the 46th. So this might be one of the problems with it, and it's probably that you didn't put parentheses on.